Hello, I'll be teaching you how to design a spiraling down staircase today. So basically we're going to start out with a circle at the bottom, specify the radius or diameter of your staircase. So let's do that, go to circle. I'm actually in 3D modeling, so if you don't have this set up, I would recommend going to this down arrow key, pressing 3D modeling. And in addition to that, use your arrow down here and make sure your show menu bar is on. So I open that up so you can see my menu bar. We need both of these to work on this project right now. So basically, we go with a circle. We create a circle we're at the top plane. I'm putting a diameter, so I type in D, enter, 60. So it's about 5 feet wide. We have something like this. Great, and we're going to create a inner circle. Will be the diameter, D, enter, 3 and a half, 3.5. So that's our inner circle and that's our exterior circle. Now if we rotate an isometric view, so I hold shift down and I hold down my scroll button and I move my mouse. That's an easy way to shift in 3D. Okay, so now we're going to extrude the inner cylinder. You can type in EXT for extrude, like so. Or we can go to your extrude command at the home tab. So we select the extrude, we select the circle, and depending on your height, let's specify this will be a 2-floor height, so I'd say about 8 feet to 8 feet, so 16 feet. I'm actually doing it in inches, that's why I have to do some math. It's about 192 inches. Correct me if I'm wrong, this probably isn't the exact correct amount, but that's alright. I'm going to copy that circle from the bottom. Let's use the copy command right here. Select it from the center point, and I'm going to zoom out and move up. Oh, there's something wrong here. Z, enter, extents. There we go. Again, copy. So how I did a zoom extents was I typed in Z enter, E enter, zoom extents, in case you didn't notice. So I copy it from center point to the center point of the top, like so. So this will be my staircase design. Next step will be the helix command, where I will take the helix all the way down. So that gives us support for the staircase. Helix will be in your draw command, helix. So we select that. We create the helix at top from the center point all the way to a quadrant. If you cannot select a quadrant, make sure you right click on your object snaps and your quadrant is on. Select the quadrant, and it's going to ask you to specify the top radius, or since we picked the bottom radius at the quadrant, which is 60 inches in diameter, we just can click it again, and that will give us a helix that is not tapered. So we're going to go all the way down, so we can either just go scroll down and select the center point of the circle. That gives us the length, or we can type it in. It was 192, but I prefer doing it this way. It's pretty simple. When we got our helix, our next step will be to actually design the staircase, and then we'll array it down, but we'll do it array path. Now, to get the correct stair type, I'm going to draw a line from the center point to where the helix begins. From there, I'm going to go back to the top view, and I'm going to do a rotate copy command, which is I select a line, I go to my rotate command, select the center point, and instead of typing in the angle right now, I put in C for copy. The good thing about 2014 is you can just select it here. You don't have to type anything in. So I select C for copy, and I'm going to put an angle of 22. That is my angle. Now, I'm not sure if I want it on this side since I don't have the helix for support. So I'm going to actually redo this. I mean, I can mirror it, but instead I'm just going to type in, select that point, copy, -22 degrees. So it rotates clockwise instead of counterclockwise. Now we have something like this. The next obstacle will be to have it a polyline so we can extrude it out to be a solid object. To do this, I prefer making a copy of the item at a specified distance. So I copy it, specified distance, make sure your ortho is on, about, I'll just say 100. That way I remember it easily. So this is my part, it's moved 100. If I need to, I can move it back 100. These I no longer need. I'm going to draw a circle again, diameter 60, or I can just snap it on, because that is the length I need. And I'm going to trim off all the parts that are not needed. So I have something like this, a small piece of pie. So we have this, now it's completed. Now we have to type in pedit. So if you look down here, pedit, enter. I type in M for multiple, or I select this item right here, and I select all the parts of this pie. I type in yes, or I leave it as a default yes, just clicking enter, and I type in J for join, and I leave it at 0, and I can click escape now. And it gives me a polyline, which now I can extrude. I can move the object back to position right now, or I can extrude it and then move it. I'm just going to move it right now. So I'm moving it, making sure my ortho's on. And I moved it 100 this way, so all I have to do is type in 100. And it moves right into the position that I needed. Now, if you accidentally wrote something a weird amount of distance, it's alright. At this point, you can still fix it by moving it to the center point. I prefer using this method because if the drawings gets too complex, you won't have a point to relate it to. So at this point, we extrude this item depending on what thickness your material is. I'm just going to do a simple 1 inch, even though the material could be 3/4 of an inch. And you can see that extruded up. I actually don't want it to extrude up, I want it to extrude down, so I will do the move command. I prefer using M enter for move, and I move from one point to the next. So now, if I go into a visual view, and I change it to conceptual, sorry about this, my computer's a little slow. There we go. I actually prefer, I prefer giving it some transparency. That way, when I work with it, I can tell where the lines are, the edges of the item. Plus, I can tell how it looks. So, I killed 2 birds with 1 stone. Alright, that's the initial setup. Next step will be our array.